Okay, 7.4, we are going to have 3 days for 7.4. This is the scary part of logs that people talk about. So just pause when you need to pause, rewind when you need to rewind. If you think you got a hang of a couple of examples, then try the others by your lonesome. The more you can do by yourself, the more it will get stuck in your head long term, and then you can begin to understand it. So part one is here. We're just going to be evaluating logarithms using this definition. So the logarithm of y with a base b is denoted by this. So this is what we want to focus on. Log base b, and try to say that as many times as you can when you write it. Log base b of y equals x, if and only if. So that means it's true both ways, if you remember that from geometry. And usually we write it like this, I and then two f's. If and only if b to the x equals y. Okay. So that is by definition. So you need to know that definition backwards and forwards. So we are going to do that 5 times. So we're going to do log base b of y equals x if and only if. And how to remember this definition is we have b to the x equals y. So it's a half smiley face. And our base, okay, our base is b, like base of an exponent. So b to the x power equals y. Right? That's once. So we're going to do that 4 more times. So we have log base b of y equals x if and only if, half smiley face, so b to the x power equals y. Okay. All right, so we have, again, log base b of y equals x if and only if, do the half smiley face, b to the x power equals y. So b to the x power equals y. All right, so if you can say that all by yourself, pause it and practice that. Log base b of y equals x if and only if b to the x equals y. Right, pause and see if you can say that, and then now we're going to write it 2 more times. So say it out loud. Log base b of y equals x if and only if b to the x power equals y. b to the x power. b to the x power equals y. Okay. And so that's by definition. So this is what you need to memorize. So the log base b of y equals x if and only if b to the x power equals y. See that half smiley face. So that's something that you should hopefully memorize. If you need to write it, we wrote it 5 times. If you need to write it 5 more times, please go ahead. It will save you a lot of hard work later. So please memorize this by the time you come to class. And then let's do, here's another couple of them. Common log, which before we go to common log, algebra 1, we know like that's x squared, but if we just write x, what is the exponent on just x? And hopefully you said x to the first, all right? But we don't really write it. We write cube roots, as we found out, cube root of x. But if we write this, what does that mean? Hopefully you said the square root of x, but we just don't write it. So the common log is a base with 10. So you're going to see log of x, and then there's no base. So we don't write it, but it's log base 10 of x. So you don't normally see it, but that's what they're talking about. So if your log is missing a base, it's going to be base 10. And then the natural log, which you kind of dealt with it a little bit, is the inverse of it. ln of x is log with the base of e, which we did graphs like that yesterday. So ln of x is log base e of x, right? So those are 2 things to put on flashcards and memorize. Here's a couple more to memorize. So you want to memorize this one, and you also want to memorize this one. Okay, so these are two special logarithm values. We're going to use these to graph, but again, log base b, which means the base could be anything. I could have a log base of, the base could be 5, 10, 20, anything. So if I have log base b of 1 equals 0, because, again, you do your half smiley face, b to the 0 equals 1. So any base to the 0 power always equals 1. So for example, if I had log base 5 of 1, that equals 0 because, do your half smiley face, 5 to the 0 equals 1. So it doesn't matter what the base is. I could have log base 25 of 1, if that and that equals 0 because 25 to the 0 power equals 1. Any base to the 0 power equals 1. So I could replace 25 with base 7, and 7 to the 0 also equals 1. So I could, that should be log. So I could replace the 7s with anything. We could have log base 8 of 1 equals 0 because 8 to the 0 equals 1. So that's something that's going to be helpful when we're solving logarithms and graphing them. Another one that's helpful is logarithm b with base b. So log base b of b equals 1 because b to the first equals b. So again, if I had log base 5 of 5, that equals 1 because, you do your half smiley face, 5 to the first equals 5. If I had log base 7 of 7, that equals 1 because if we do the half smiley face, we'll get 7 to the first power equals 7. So, and then we could replace the 7s with anything. We could replace, let's see, try anything. We could do 10. Log base 10 of 10 equals 1 because 10 to the first equals 10. So that's true for all the bases, right? And that's going to be helpful. So now we're going to do a little bit of evaluating logarithms. So we're just going to go back and forth between logarithmic form and exponential form. So exponential form would be the happy face. So log base 2 of 32 equals 5 because 2 to the 5th equals 32. And that's all you're writing here. So for part B, let's see, we have the base. We know the exponential form. We're trying to put it in logarithmic form. The base is 7, so I at least know log base 7 of something equals something. So let's try it. If I just put 1 and 0 here, does that work? 7, and I can double check. 7 to the 0 does equal 1. So that's what I wanted. If I mixed them up, and then I double check, let's see, 7 to the first power does not equal 0, so I know that I messed that up. All right, so take that away and replace it. Okay, so please pause the video and do C and D by yourself to make sure you really understand it. So pause the video. Now, if you did the half smiley face, good job. That's going to help it get to long-term memory. But 13 to the first is 13, so if you did that, awesome. Right, and then this one, what is the base? What is the base for this one? This is the base right here, so this is going to be log base 1/2. And then we could put 2 equals -1, and we can just double check. Right? 1/2 to the -1 equals 2. And is that true? Does it really equal 2? Well, if I distribute this -1, I get 1 to the -1. over 2 to the negative 1. And then those are both unhappy upstairs and downstairs, so I flip it and I get 2 to the first over 1 to the first. And 2 over 1 is 2, so that does check out. All right. Guided practice, same idea. You're just going to rewrite all of these in exponential form. So if you want to do that now, great. If not, you can wait till in practice or in class. Example 2, we're going to evaluate these logarithms without a calculator. So example A, there's two ways to do this. We're just going to use the definition. So I'm just going to make that equal to x, and then I can do my half smiley face. So 4 to the x equals 64. And then I can say self 4 to what power equals 64? And you would say x equals what? 3. Good job. Right? So for b, we don't know what that is, so we're going to equal it to x. And then we can do our half smiley face. So 5 to some power is equal to 0.2. Right? So it's some sort of fraction. So what could it be? 5 to the first would be 5, so that doesn't work. And it's a less than 1, so let's try, if I did 5 to the negative 2, I could check that out. That's 1 over 25. And if I were to put 1 over 25 in my calculator, is that the same thing as 0.2? So, nope, you get about 0.04. So it's definitely not negative 2. So maybe let's try negative 1. So 5 to the negative 1 power, that's the same thing as 1 over 5 to the positive 1. And 1 divided by 5 is 0.2. So we found it. So x is equal to negative 1. Right? All right, so for part C, see if you can do part C and D all by yourself. So pause the video, see if you can do those two, and then if you don't, forward to check your answers. If it doesn't work, then check back with me, rewind. But pause it, see if you can set it up, at least set it up all by yourself. You can do that part. So our half smiley face would be 1/5 to some power equals 125. All right, so this is similar to B, where, let's see, if it was 1/5 to the negative 1 power, I'd have to flip-flop it. So 1 to the negative 1 over 5 to the negative 1. That's the same thing as 5 to the positive 1 over 1, so we just get 5. So 5 and 125 are not the same thing, but let's see, I could try 1 over 5 to the second power. That would be 5 to the positive 2 over 1 to the positive 2. And that would be the same thing as 25. So let's see, what could it be? All right, if you are yelling negative 3, you are correct. So if I flip-flop it, make it positive 3, 5 to the positive 3, 1 to the positive 3, I get 125. So my answer for this one is x equals negative 3. Good job. And for part D, I'm going to set this equal to x. And then if you didn't set up C, please set this one up. You can do it. Set this one up. So you're going to have smiley face 36 to the x equals 6. Okay, so that one, let's see. 36 to the first power would be 36. And 36 to the negative 1 power would be 1 over 36, so that's not going to quite cut it. So we're looking at a fractional exponent. So if I do 36 to the 1/2 power, let's see, that's the same thing as the square root of 36, which is 6. So my answer for this one is x equals 1/2. Okay? So logarithms are a little bit difficult because it looks like you're doing something for each problem differently. Okay. Our test will be no calculator. but it's important to use one for the word problems. So let's see. If your calculator is backwards, you're going to do 8 first and then hit log. But if you do not have one, then you're just going to do log 8 and you should get 0.903, okay? And that's log base 10. Your calculator is only log base 10, so if you have a log base 6, it's not going to help you. And then ln, you were using ln, but just the e to the x in class today, but ln of 0.3, put that in your calculator, you should get negative 1.2. Right. If you don't get that, let me know, I can help you. And then our favorite word problem. So read the problem, figure out what you're trying to find and what you have. So pause the video, figure out what you have, what you're trying to find. Let's see. S is the wind speed. D is the distance. And you're using this formula. S equals 93 times log, and there's no base, so that's base 10, which you can choose to write or not. And then let's see. Estimate the wind speed. So what is the wind speed? Is that S or D? We want to estimate the wind speed. So is that S or D? If you said S, good job. All right, so what do we have? Let's see, it traveled 220 miles, so that part is D. So we have D, so I'm going to replace this D with 220 miles. So, and then we're going to solve for S. So we have S equals 93 times log base 10 of 220 miles plus 65. So order of operations, we're going to do this part first, then multiply by 93 and add 65. So go ahead and do that by yourself. And hopefully you got log base 10 of 220 is about 2.342. And then order of operations, you're going to multiply first. So you should get about 282, 8.06. And so we're solving for wind speed. So the tornado was going about 283 miles per hour. Just a bit fast. Right. Again, if you are struggling at all in this class, you might want to pause the video, cover up your work, and do this problem again without, just think through it all by yourself. Sometimes that helps too. Guided practice, let's see, 5 and 6, no calculator. So don't use a calculator. You can't because it's log base 2 and you don't have log base 2 in your calculator, but just to make sure, 5 and 6 no calculator, 7 and 8 you need a calculator. And number 9 you can completely do. So figure out what S is, figure out what D is, and what you're trying to find. Okay. And then we've got more examples. So for these, if you got the hang of it, go ahead and pause it and do all of these problems. Okay. If you don't have it, then stand by. But let's see. At least set them up. So we're going to set them up all the same. This equals x, this equals x, this equals x, and this equals x. So go ahead and rewrite it in exponential form. Right, so what would this one be in exponential form? 4 to the x power equals 64. Good job. And we've done that one, but we can do it again. This one, 1/4 to the x power is equal to 256. So you're probably thinking something negative. And then this one, this is actually log base e. So if I write this as log base e of 1 equals x, then this would be e to the x equals 1. Sometimes that helps to rewrite it in log base e. And this one would be 22 to the x equals 22. So if you can figure out most of these, pause the video and see which ones you can figure out. So for this one, x would be equal to 3 because 4 cubed is equal to 64. Okay. This one's a little bit tricky. 1/4. Let's see. Well, we might need to do some exploring. So I'm not sure, but maybe if it was -2, that might help. So we have 1 to the -2 over 4 to the -2. And if we flip-flop that, we'll get 4 squared over 1 squared, which is 16. So we're on the right track, but not close enough. So let's see, if we flip-flop with -3, we'll get 64. Let's see. So let's try -4 instead of -3. Right. So 1/4 to the -4 power. That's the same thing as 1 to the -4 over 4 to the -4. And we flip-flop it, so we have 4 to the 4th over 1 to the 4th. And 4 to the 4th is 256 over 1. So we found our answer. X is equal to positive -4, JK, -4. Okay, this one, let's see, e to some power equals 1. So hopefully, any base to some power equals 1. So hopefully you should x equals 0, because anything to the 0 power equals 1. And then for part D, we have 22 to the x equals 22. And that can only be with x equals 1. 22 to the first power equals 22. So if you got those a long time ago, awesome, good job. Right? And then here is your last guided practice, 11 and 12. Right? So that is the end of this video. And again, if you can do all of this by your lonesome, great. If you can get started listening and then do most of it by your lonesome, that's good too. So please try to do as much as this on your own and then always double check the notes. See you tomorrow.